Oh, yay. Hello, hello, hello. Well, welcome to our unit test review for moving straight ahead. Why don't you tighten up those suspenders and put down those maracas. Let's go to work. Hopefully you have a copy of this, and if you don't, maybe just pause and maybe take a picture of it, pause, work on it, and then let's see how we did together. But I'm going to get right to it. All right, I'm going to do this equation right here. So a couple things I need is, in order to make the equation, I need the slope, which it's asking for, and the y-intercept. All equations have that. So actually I have the y-intercept, it's right there. So because the coordinates at 0, 4, the y-intercept is the 4. So I already know that in my equation. I could build it right now, but I need my slope to get going. So for slope, I'm going to use points that I know exactly where they are. Like this point right here, I don't know where that is, so I'm not going to use that. And like these points right here, not helpful. So I'm going to use coordinates I know. Like I know where that point is, and I scroll down and I know where this point is. So I know where these two are. So really, the rate of change is asking what is the change to go from one point to the next point. Well, this point goes down 2, so it drops 3, not 2. And then it goes forward 4. So we've heard maybe that phrase before where you rise and run. So how much does it rise? And actually this one drops, but we can't say rise or drop over run because that doesn't even sound very fun, but we do rise over run. So this one rises -3 and runs 4, so it creates the ratio of -3 over 4. So once I have this and I have my y-intercept, I can build my equation. So the slope of this line is -3/4. And some people say, well, if the top is negative, is the whole thing negative? The answer is yes. It is all negative. Yay. If the top is negative and the bottom is negative, that's positive because a negative divided by a negative is positive. So be careful on that one, that situation. Let's make an equation of this line. All right, so y equals, and I need my slope, which is -3/4, which is also my rate of change, which is also my coefficient, x, and then it's 4, but it's +4. It's above it. Yay. Next one. Press pause if you haven't. See if you can find this yourself. Well, you got this. Look at the y-intercept. It's right there. Oh, it's also 4. Huh, how cute. Now let's find any 2 points. Here's one, and here's one. Nice intersection. You can find any one you want. So I'm checking how much it rises, which it actually does go up, 2, and then over how much does it run, and it runs 1. So it rises 2 and runs 1. So this slope looks like it's 2. Let's say that I use a couple different points. Let's say I use this point, and then I use a point up here. It rises 4 and runs 2. So the ratio is 4 over 2, which also equals 2. So you really can't mess this up. All right? So the slope is 2. Actually, the slope is just the coefficient. So just write down the number, not the variable. Let's do our equation. It's my slope, and my y-intercept is 4, which is +4. If it was down here, like if my line went through this, I would use -6 as my y-intercept. So a little quinky dink. All right, let's keep going. Don't stop. Let's keep going. Does the table represent a linear relationship? Okay, so what I'm going to notice here is I'm going to notice that these times don't jump in a nice order. It doesn't go like 1, 2, 3, 4, 5. If it did that, it'd be really nice because we would see if this is changing at a consistent rate, which would mean it's linear. But they don't. Another way to see if something's linear is if you graph it and just see does it make a straight line, but there's no graph paper. So I need to use a different strategy. So I'm going to look at how much they change between each one. So let's go between here. So between 1 and 3, it changes 2, and between 8 and 14, it changes 6. Now, I'm gonna work on my ratio, okay? Remember, my ratio is rise over run, okay? And that's change in y over change in x, right? Is that coming back to you? So that's gonna be, so my change in y, which is this number, okay? Here's my x. My y is right here, this stuff. So my change in y is 6 over my change in x, which is 2. 6 over 2 is 3. So that's the slope of that situation. But I got to compare it with another one because I got to see, is it consistent? So 3 over 8, the difference is 5. 4 to 29, the difference is 15. So it rises 15 and runs 5. They're the changes. 15 divided by 5 is 3. Oh, man. I'm going to do one more just to make sure it's true, because you got to do 3 to make sure it's true. 8 to 12 is 4. 29 to 41 is 12. And so it rises. It's y over x. So the change in 12 over change in 4. 3. Ding. Ding-a-ling. Ding. Shazam. Is it linear? Yes, it is. Explain your answer. I did right there. Boom shakalaka. All right, run and take a nap if you need to. No, not a nap. Just grab a snack and then hustle back here. But press pause first so I'm not talking in this room by myself. Like, that's not fun. All right, let's keep going. So I got an equation here. A couple strategies are to pause it and solve it yourself, and then come back and let's see how we did. But I'm going to look at my equation. It's got 2 sides to it. I'm going to look at the side with the variable, and I'm going to undo what I see, okay? So I see adding, so I'm going to undo that by subtracting, and I'm going to subtract 4 from both sides. So I have 4x. 4 minus 4 is 0, so that zeroes out. 32 minus 4 is 28. Again, I'm going to look and see what math I see. I'm going to look at the side of the variable. What math do I see? I see multiplying. How do I undo multiplying? With division. I'm going to multiply by the entire coefficient by 4, because 4 over 4 is 1, which is x. 28 divided by 4 is 7. Now, I could be super excited that I have an answer and just be done, or I substitute it in and see if it's true. 4 times 7 plus 4, does that equal 32? Now, the reason why I put the 7 in right here, because I found out what x is. X equals 7. So 4 times 7 plus 4 is 32. Fiery check mark. That answer is right. Boom shakalaka. Whoa. Holy beans. I got x's and stuff everywhere. So let's deal with the x's first. I'm going to subtract 2 x's from both sides. Boom. And I've got 10 equals, so x's are gone. I've got 2x plus 14. Now, I could do either way. I could subtract 10 from both sides. I could subtract 14 from both sides. I'm going to subtract 14 from both sides because I want to deal with the side with the variable. So 10 minus 14 is negative 4. Negatives aren't bad. Just got to pay attention to them. Most students do that. They lose track of the negative, but that won't be you, right? It'll be the kid next to you, not you. Let's keep an eye on that negative. All right, I see multiplying here, so I'm going to divide, and I'm going to divide by the entire coefficient. And why I keep saying entire coefficient, because if this was negative, I'm going to take the negative with it. That's what I keep meaning. 2 over 2 is 1, so that's x equals negative divided by positive will be negative. 4 divided by 2 is 2. So 10 plus 2, where's my 2? I'm checking it. 2 times negative 2 equals 4 times negative 2 plus 14. So if I add that up, 2 times negative 2 plus 10, and negative 2 times 4 plus 14, those are equal. Fiery check mark. Yeah. Whoa. Holy bacon, Batman. What's going on here? Okay, we got a couple different ways to do this. One way we could do this is, I call this, I know, for those that don't know me, I call this a Happy Meal inside that parenthesis, just because I think it's weird, and I can be kind of weird here. So this is a Happy Meal, and I need 5 of those Happy Meals. So if this X is my hamburgers, I need 5 hamburgers. And if the 2 is fries, and the deal already comes with 2 fries in it, I need 5 of those. So that's going to be 10 fries. I know, isn't that weird? But it's one way to keep track of it. So really, 5 times x plus 2 is 5x plus 10. It's called the distributive property. All right, let's clean this up. Subtract 10 from both sides. 5x plus 35 minus 10 is 25. Mr. Rober, do I need to show all my work? Yes, because really this is about process. It's not just about can you do stuff and get to the answer. It's about do you have a good, healthy process to get you there? Because you want to have a process, because eventually these numbers get kind of chewy. Like, these numbers won't always stay clean and nice and easy like these. So 5 plus 2 times 5, total 35. Correct answer. Hey, do you want to see the other way to do it? If you don't, you can fast forward, but I'm going to show you another way real quick if you're interested, because something I noticed about this equation here is that the 35 is that the 5 and 35 go into each other nicely. So what you can do in this situation is divide everything by 5. Okay, when you divide everything by 5, you end up with x plus 2, because that 5 is completely gone. 35 divided by 5 is 7, right? And you go minus 2, x equals 5. You land in the same spot. You got options. Options. Let's keep going. Oh, look at this. It's like matching. Yay. Let's do a little matching. Matching. All right. So so this is what I do. In order to compare things, I look at the y-intercept because you can see it really fast if you can see it in the table. So I look in the table and I see that according to this one, this y-intercept goes to the origin, which means it's proportional. So I'm going to look at my graphs and see which one goes to the origin. This one goes to the origin. And I'm going to look at my equations and which one goes to the origin. The one where the y-intercept is 0, which is right here. So right now it seems like graph A, or table A, graph C, and equation F go together. Let's take a look at this one. This goes through -1 as the y-intercept. Look at the y-intercept goes through -1. The y-intercept is -1. So to figure out matching on these kind of things, I use the y-intercept. If sometimes the table you don't have like the y, or yeah, you can't find the y intercept because maybe 0 doesn't show up in the equation, you can find it if you want, but you can just look at the graph a little bit. Nice. All right. Whoa, story time. But look at it. It's our last one. Oh no, got a little bit. Actually, this story takes a couple pages, so here we go. Let's go to work. Online movie streaming has 2 options. Plan A, okay, say we pay $55 for a year membership, and then $2 per movie. That seems important. And then the other one, you just pay $4.50 per movie. Okay, so let's make the equations of these. Let's just build the equations now. Okay, Plan A says $50 for a 1-year membership, so you just pay that once. So the amount of money that I need to pay is going to be, let's see, amount of money I'm going to pay is going to be, looks like it's at $50. Like I have to pay $50. And $2 per movie. So it looks like they want us to use N, which makes sense because I'm already using M for money. So I don't want to use M for movie also. Okay, that's fair. And then Plan B is $4.50 per movie. Hey, if you didn't try these before I did, you try them. Okay, give them yourself. The cost is going to be $4.50 per movie. All right, let's fill out this table. Number of movies, how much money it's going to cost, number of movies, how much it's going to cost. All right, so let's build this. 0, 10, 20, 30, 40, 50. 0, 10, 20, 30, 40, 50. If I'm going too fast, just pause it and come back. And press play when you got it all set. The reason why I did this is because it told me to do that. From 0 to 50, increments of 10, check. Makes you start at 0. Because we need that because it's going to give us the y-intercept. All right, so let's go to work. Plan A, that's this guy, 0 movies. So 2 times 0 plus 50 is 50. 10 movies, okay? 10 times 2 is 20 plus 50 is 70. 20 movies. 20 times 2 is 40 plus 70 is 90. Okay, now because this goes up by a pattern, I can do the pattern on this one. So 90, 110, 130, 150. Yes. Go me. Go you. Go use the restroom if you need to. All right, back to this. All right, so Plan B says this. So this is 0 movies. 0 times 450 is 0. 10 times 450 is $45. 20 times 450 is 90. 30 times 450 135. 40 times 450 is 180. 50 times 450 is 225. I'm going to start just setting up this graph a little bit here because I want to graph both of them on the same line. So you're going to have 2 lines that show up on here. Okay. On the bottom, let's see, the amount of money you paid depends on how many movies you get. Totally true. Let's do 0, and I'm going to go by 5 so I can spread this puppy out. 20, 30, so you keep going with that one. And for money, I'm going to go by 25s, but I'm only marking like the 50s just because I write huge. All right, and finish up. All right, Once you do this, press pause, graph your 2 lines, because on the next slide I have it all built, and we'll talk about it. So press pause, you build it, and let's see how you did. I'm scrolling, hope you paused it. Hope you paused it. Don't watch me do math, you do math too. Oh, there it is, look at that. There they are. Nice, right? That looked fantastic. Okay, plan B goes through 0, 0, which is the origin, which matches the equation. Because look at this right here, there's no, the y-intercept is 0 on there. Totally true. And then the next one right here is, this goes through 50, which starts at 50, which is the y-intercept in our equation, right? That's pretty good, and they're both at a steady rate. The blue one is proportional because it goes to the origin. The orange one is not proportional. Okay, nice. Good job on the graph. Now, one thing I did on graphing, notice that you don't see any like dots in here. It's because the dots were too wonky. Like I couldn't tell where they went, so I didn't plot them. I plotted the ones that I knew where they went, and I used the dots that I knew where they were to draw my line. And when you draw a line, try to use a straight edge, because that's really important. All right, the equation we already built. Okay, I'll write it down for you. We'll write it down again so we can get it. So y equals, it starts at 50 and it changes $2 each time. And the equation is y equals, it's $4.50 per movie. And I believe we used letters for these. So we had an N for this one and maybe money for this one. What's the slope? The slope is 2 for the first one and $4.50 for the second one. What does the slope tell you? It is actually the price per one movie. That's what they always tell you. What does the y-intercept tell you? It tells you where it starts, or the starting fee. For what number of movies will it be the same? I need to find the intersection. So explain how you found your answer. I can go to my graph. I can say C, graph. I'm going to go to graph, and I'm going to look up here, and it's right in that spot. And where does that happen about? It looks like it happens about right here, which seems like it's about 20 movies. It's not asking money, it's asking movies. So down here, I'm going to put 20 movies. Whoa, did I spell movies weird? M-O-V-I-E-S. 20 movies. Wow, Mr. Rubber, work on your handwriting. All right, so how'd it go? Done! Yay! Excellent. All right, good job. Make sure you practice what you need to practice. Hopefully there was some things. You can do this again. Find the things you need to work on. All right, I'm going to go tickle the feet of an octopus until it farts.